The departure procedure you use during an IFR flight varies from airport to airport. Sometimes it may be as simple as a climbing turn to your intended course. At other times, it may involve a complicated set of courses, altitudes, and vectors. Therefore, before making an IFR departure, you should acquaint yourself with the procedures which are available at your airport. By regulation, before any IFR flight, you must check the en route weather and the weather at your destination and departure airports. For commercial flights operating under Part 121, 125, or 135 of the Federal Aviation Regulations, certain visibility requirements must be met before a takeoff is allowed. While these minimums are not required for flights conducted under Part 91, they are good guidelines for you to follow. For aircraft with 1 or 2 engines, the standard visibility minimums for takeoff are 1 statute mile. Because some airports have obstructions such as rising terrain, a minimum ceiling, as well as an increase in the visibility, may be required. If the minimums are higher than standard, they will be noted on NOS charts by a triangle symbol enclosing a T. This symbol is found in the information box and can also indicate that departure procedures are published. To determine the exact minimums, you need to refer to the IFR Takeoff Minimums and Obstacle Departure Procedures section in the front of the Terminal Procedures booklet. For example, at Daytona Beach, the takeoff minimums for runways 7 right, 16, 25 left, and 34 are a 300-foot ceiling and 1 mile visibility. Jeppesen prints this information on the airport chart. Since the takeoff minimums are normally based on visibility, let's look at the various types which are reported at an airport. Prevailing or tower visibility is the greatest distance a weather observer or tower controller can see throughout at least 1/2 the horizon circle. It is measured in statute miles or fractions of miles. Runway visibility value, or RVV, is the distance down the runway that you can see unlighted objects or lights of moderate intensity. This value is generally derived from an electronic measuring device and is listed in miles or fractions of miles. When available, RVV is used instead of prevailing or tower visibility. The most accurate reading of visibility along a specific runway is the RVR, or Runway Visual Range. This value is based on measurements from transmissometers located near the runway and relates the horizontal visibility in hundreds of feet. An RVR value of 12 means that the visibility is 1,200 feet. Since the visibility may vary from one runway to another and at different portions on the same runway, especially at larger airports, the RVR value should be used only for the specified runway. Once you have determined that the weather will allow you to make a takeoff, you need to consider what type of departure procedure you're likely to use. When departing an airport, you must climb at a rate of at least 200 feet per nautical mile. This allows at least 48 feet of obstacle clearance for every nautical mile you travel. If obstacle clearance requirements are not met, a textual or graphic departure procedure will be published. These departures are designed according to the criteria established in the United States Standard for Terminal Instrument Procedures, abbreviated TIRPS. NOS publishes the obstacle textual departure procedures with the takeoff minimums at the beginning of the Terminal Procedures booklet. Jeppesen prints them on the airport charts. Departures from airports near large metropolitan areas are usually conducted under radar coverage. A series of heading assignments, called vectors, are provided to transition you from takeoff to the en route portion of your flight. In these cases, the tower generally gives you an initial heading to fly. A short time after liftoff, the tower will instruct you to contact departure control. After changing to the departure frequency, your initial call should include your ID, current altitude, and the altitude to which you're climbing.
Departure Cessna 52241, 2,500, climbing to 5,000.
By stating your current altitude, the controller can verify the accuracy of your Mode C transponder.
Cessna 241, roger, radar contact.
Radar contact is used by the controller to let you know that your aircraft has been identified. However, it is your responsibility to maintain adequate obstacle clearance until the controller issues you a vector or other instructions. Departure control will then give you specific headings to fly in order to intercept your clearance route. Once the final vector has been given, the controller will tell you to resume own navigation. This phrase means that the controller now expects you to navigate using your own equipment. It does not mean that your flight is no longer in radar contact. When departing an airport without an operating control tower, some additional procedures may apply. For example, you might use a ground communications outlet. You may be issued a clearance void time. ATC uses this procedure to reserve airspace around the airport. If you do not depart before this time, your clearance will be canceled. When climbing to your assigned altitude, ATC expects you to climb at the optimum rate for your aircraft until you're within 1,000 feet of your target altitude. Then slow your rate to 500 to 1,500 feet per minute until you begin to level off. If you cannot maintain at least 500 feet per minute throughout the climb, you must notify ATC of your actual rate. In addition to providing obstacle clearance, at busier airports, instrument departure procedures, or DPs, expedite the flow of air traffic by reducing the length and complexity of issued clearances and by cutting down on pilot-controller communications. As with any IFR departure, DPs also assure adequate obstacle clearance. Some instrument departure procedures contain specific performance requirements in order to maintain adequate obstacle clearance. You should always review the graphic instrument DP chart you're planning to use to verify that your aircraft can comply with the required performance criteria. If you cannot meet these requirements, you should request no DP on your flight plan. A graphic instrument departure procedure requires you to fly a specific route and altitude combination after takeoff. For example, let's take a look at the Gorman transition of the Merrick 3 departure at Bakersfield, California. To fly this pilot nav departure procedure, first look at the takeoff information for the runway in use. In this case, as soon as you take off from runway 12 left, you're required to make a right turn to a heading of 240. From there, the procedure calls for you to intercept the 196-degree radial of the Shafter Vortac and proceed to Merrick intersection. To reach Gorman, fly the 109-degree radial of the Avenel Vortac until you intercept the 328-degree radial of the Gorman VOR. Then fly direct to Gorman VOR. From this point, proceed according to your flight-planned route, unless otherwise instructed. Notice that Ninty intersection has a minimum crossing altitude of 8,800 feet for the Gorman transition. If you are using the Lake Hughes transition, the minimum crossing altitude for Ninty would be 6,000 feet. These altitudes are necessary to achieve the minimum altitudes along the transition routes. As you have seen, an instrument departure procedure can take many forms and is frequently changed. Because of this, it's important that you understand the procedure and its requirements on you and your aircraft before you take off.